Alright guys, so here at the end of chapter 1 we're going to look at some word problems and how to solve word problems with linear equations. There are three types of word problems we're going to focus on in this video. Number problems, consecutive integer problems, and geometry problems. So we'll look at all three of those types and just make sure that for all of the problems that you check your work and write your answer in a complete sentence. If the problem is put to you in words, you should answer in words. All right, let's take a look at the first type. So the first number problem that we're going to look at just requires us to tell a story. Let's start by reading the problem. 3 more than twice a number is equivalent to 5 less than triple the number. Find the number. So when I look at this, I realize that I'm going to have to figure out what the number is, and therefore that's going to be my x. Now I have to just tell a story based on that. 3 more than twice a number. I'm going to translate that right now. 3 more than twice a number. Well, twice a number would be 2 times that x. That's what twice means. And 3 more than that means that I'd add 3. Now it says is equivalent to. Well, is equivalent to is just a fancy way of saying equals. And then we have 5 less than triple the number. So triple the number, I'm still talking about that x, so that's 3x. 5 less than that is minus 5. Now I can go ahead and solve this equation. So I'm going to do that. So I end up getting x equals 8. And now I can check that just by kind of going back into my problem here. If I think about what's 3 more than twice a number, that's going to be twice 8 plus 3, which is 16 plus 3, which equals 19. And that should be equivalent to 5 less than triple the number, so I'll do 3 times 8 minus 5 is 24 minus 5, which is also 19. And so I have my answer because these check out. Now, it may seem silly, but I'm just going to write a quick sentence to show this. Just a simple sentence like the number is 19 is all that I need. All right, so that's just one classic number problem. Let's take a look at another. All right, another number problem here. We're still going to tell a story. The second of 4 numbers is quadruple the first. The third is 6 more than the first. And the fourth is 3 less than double the first. Find the numbers if their sum is 19. So this is a little bit more complicated. We have 4 numbers to find. So now everything seems to be based on the first number, so I'll call the first number x. So now I want to list these all out. So the first number is x. The second number, the second of 4, is quadruple the first. So quadruple the first would be 4 times x, or just 4x. The third is 6 more than the first. So the first is x, 6 more than that, plus 6. And the fourth is 3 less than double the first. So I have to do double the first is 2x, and then 3 less than that is minus 3. So those are my 4 numbers. They're not necessarily in increasing order. Those are just my 4 numbers. So now I use this last line here to get up my equation. Find the numbers if their sum is 19. Well, I know that sum indicates an addition, so I'm going to add all 4 of these things up. And so when I have x plus 4x plus x plus 6 plus 2x minus 3, I set that equal to 19. Now I'm just going to combine like terms and solve the equation. So when I solve this equation, I end up getting x equals 2. And I'm going to go all the way back now to the original 4 numbers that I have and identify what each of those numbers is. Well, my first number is just x, so that's 2. My second number is quadruple that. 4 times 2 is 8. 8 is quadruple 2. The third number is 6 more than the first, so 2 plus 6 is 8 also. Oh, okay, I have 8 in both cases there. And the fourth, is 3 less than double the first. So 2 times 2 is 4, minus 3 is 1. And so those are my 4 numbers. If I add up these 4 numbers, 2 plus 8 is 10, plus 8 is 18, plus 1 is 19. So they do have a sum of 19. That's my check. And now we'll just write a quick sentence. And so there we have it. The four numbers are 2, 8, 8, and 1. And that's it. That's how you do these number problems. Hope that makes sense. All right, the next type of problem we're going to look at are consecutive integer problems. And with these, you have to be very careful with your variables. Now, there's three different ways the problem could be set up. You might be told that you have consecutive integers. That would be something like 7, 8, 9, just going on and on. When that's the case, you're going to start with x, and you're going to go up by 1 each time. X plus 1, x plus 2, x plus 3, and so on, however many you need. Another option would be if they're consecutive even integers, something like -2, 0, 2, 4, 6, 8. It would continue from there. You're still going to start with x there, but you'll notice that each time you're going up by 2. So now you're going to have x plus 2, x plus 4, x plus 6. All right? The last type is consecutive odd integers, and this is where people tend to make the most mistakes. If you're going 3, 5, 7, 9, 11, and so on, again, start with x, but even though they're odd integers, we're going to be going up by 2. That seems strange until you remember that to get from an odd number to the next odd number, you have to go up by 2. And so if they're consecutive even or consecutive odd, your setup will actually be exactly the same. If it's just consecutive integers, go up by 1. For consecutive even or odd integers, go up by 2. All right, let's give it a shot. Our first problem here is probably the most classic of all the consecutive integer problems, just a general sum problem. We want to find 3 consecutive odd integers whose sum is 57. So first going to set up our variables, 3 consecutive odd integers. I know I'm always starting with x, and then odd integers I go up by 2. So I'm going to have x plus 2, and then the third one is x plus 4, going up another 2, and I only need 3. 1, 2, 3, I have them right there. Now I'm being told that their sum is 57, so I'm going to add those up. So I have x plus 2 plus x plus 4 equals 57. Now I'm going to go through and solve this equation. And so I end up getting x equals 17, which I'm then going to come back over here, just like on some of my number problems, and fill in the rest of the information. Certainly know that my first integer is 17. X plus 2 would be 19, and x plus 4, 17 plus 4 is 21. Clearly, these three numbers are consecutive odd integers, and their sum, if I add them up, does equal 57, and so I'm done. I have my answer. Now I can just write a sentence, and I will be done. And so I can just state that the 3 integers are 17, 19, and 21. And there we go. All right, let's try one a little bit more complicated with these consecutive integers. So here we have an example where we're trying to determine 4 consecutive integers such that the second is 4 greater than 1/3 of the fourth. Okay, so a little bit more complicated. So let's start off by writing our variables. 4 consecutive integers, not even or odd. So consecutive integers would be x, x plus 1, x plus 2, and x plus 3. All right, so now I'm going to write an equation. And I know that this says that I need to have the condition that the second is, so the second one is the x plus 1, and is means equal, 4 greater than 1/3 of the fourth. So 1/3 of the fourth is 1/3 of x plus 3. I have to put that in parentheses. And then 4 greater, so I'm going to add 4. All right, so now I have to go ahead and solve this equation. It's going to start with the distributive property, but let's see what it looks like when it's solved. So a couple of ways you could go through solving it, but the way I've done it will work the way as any other, and ultimately give me x equals 6. So I know at that point I go back up to my original variables, identify what I have. X is 6. X plus 1 is 7, x plus 2 is 8, and x plus 3 is 9. Clearly they are 4 consecutive integers, and I just want to do the check, make sure that the second is 4 greater than 1/3 of the fourth. So if I look at 1/3 of the fourth, which is 9, and get 4 greater than that, then 1/3 of 9 is 3, plus 4 is 7, which is in fact the second. So that's what I wanted to have, and that's my answer. So now I can write a sentence. And so I can just write that the integers are 6, 7, 8, and 9. And then I'm done. All right, let's move on to geometry. So a lot of the geometry problems will use different facts to help you set up equations. Some of the facts that you'll want to know are that the angles of a triangle add up to 180 degrees. The perimeter of a figure is the sum of all its side lengths. The opposite sides in a rectangle are the same length. Squares have 4 sides of the same length. There's lots of different facts that you need to know, but most of them you've covered for many, many years in your schooling, so we should be good to go. Let's see exactly what this looks like with an example. All right, so this is a problem about triangles. We're told that 2 angles in a triangle are the same size, and the third angle is 4 less than triple the sum of the other 2. Find all 3 angles. So I'm going to start with the diagram. So I have my triangle, and 2 angles are the same size. So I'm going to call them each x. And I'm not going to write degrees on there now just because it'll be a little crowded, but those will be measured in degrees. Now the third angle is 4 less than triple the sum of the other 2. I'm not going to fit that in there, so I'm just going to draw a little arrow. Triple the sum means 3 times x plus x. I know that right there. And 4 less than that is minus 4. So that's going to be that angle right there. If I wanted, I could even make that 3 times 2x minus 4, which is going to be 6x minus 4. And so now all I have to do is I actually have to add up these 3 expressions and end up getting 180 degrees because that's what the angles in a triangle add up to. So my equation is going to be 6x minus 4 plus x equals 180. So now I go ahead and I solve this, starting by combining like terms, and then solve the equation. So we see that we get x equals 23. I plug that back into my expression here to get 134. And I find that these 3 angles are 23 degrees, and 134 degrees. We can do a quick check. Those 3 do add up to 180 degrees. And in fact, the third angle, if I do triple the sum of the other 2, triple the sum would be 46 times 3, which is 138, and 134 is 4 less than that. So there we go. That is a geometry example. Hope this is clear.